Jaluskis! All my pretty out peoples all over the world. In the Russia, in the Ukraine, Chilos. Alright, so in this video we're going to be talking about solving trig equations. So a regular equation, you'd have like 2x plus 1 equals 7 or something like that. And then you would subtract 1, do. This is algebra 1. If you don't know what I'm doing, I am very, very sad. So then x would equal 3, right? So we're going to be doing something like that, except we'll have something like tangent x equals square root 3. And then we can figure out what angles x is equal to. Opposite over adjacent, pi over 3, or else is tangent positive is t 4 pi over 3. So this is back to the unit circle stuff. Like I said, you need to know it.
I told you, you didn't listen to me, but I told you.
Okay, so we're going to be solving on the interval 0 to 2 pi. Not super important to know, it just means that it's not going to include any of our coterminal angles. Biggest thing here in solving, you're going to try to get the trig function by itself. So in this one, I have my trig function tangent, yes. So I can subtract 3 tan x and subtract 3 tan x. I don't know what I just said, but that makes 0 on that side. You can add the 7 plus 7. Yay, we're doing math. Woo! What's this math thing? So then I just have tangent of x equals u1. Well, now you just have to give me the angles where tangent x is equal to 1. Don't forget about triangles. Yes. Sub prete. Not really, but prete. Prete 1, 1, square root 2. Yes. And all students take calculus. Because if tangent is a positive function value, then it is in the first or the third quadrant, where my reference angle is pi over 4, because tangent is opposite over adjacent, so 1 over 1 would be 1. So x would be pi over 4 and 5 pi over 4. This one puts me in the first quadrant with a reference angle of pi over 4. This one is in the third quadrant with a reference angle of pi over 4. If you don't remember the unit circle stuff, go back, look it up. Please, come on, man. Next, yes. Subtract 7. Ooh. 4 equals 3 choices and squares. Divide by 3. 4 over 3 is equals choices not squared x. How do I get rid of squared? I took a square root. If I take a square root, I must put positive or negative. 2 over square root 3. Yes, square root of 4 is 2. Yes, it is. Square root of 3 is square root of 3. Yes, it is. Equals cosecant x. Yes. Now, if it's positive or negative, that means it's going to be any quadrant, right? So you can, because you have S to C, all positive, sign negative, right? So that means cosecant's going to be everywhere. So all we really have to figure out is such that hypotenuse over opposite is 2 over root 3. Well, that comes from your pi over 6 triangle, pi over 3, root 3, 1, 2. So then just put your reference angle as opposite has to be from there, so you pi over 3, so you have pi over 3. 2 pi over 3 is the one in the second quadrant, 4 pi over 3 is the one in the third quadrant, and 5 pi over 3 is the one in the fourth quadrant. So x equals, there are our solutions. Make sure when you take the square root, you put the plus or minus, otherwise you are missing half of your solutions. So I don't know why I thought about this, but I started to look up Banana City, and there's all these crazy things about Banana City. 19 cents each. Banana City! There's Banana Island. It's just funny. That doesn't make sense to me. There's just girls sitting at a table. Yeah, banana shoes. And then I remember that there's actually a city called Banana, Australia. You can look it up. It's a real thing. I don't think it's on there, though. Is it? Is it? We can't read it. Focus. No, it's somewhere in here though. Somewhere in there. Banana Australia. Look it up. Yay, more! More! Please! Okay. So with this one, I notice I have a sine and I have a sine, so if I add this to the other side, sine x, cosine x, that's a term all to itself. So then I have negative 2 sine x plus sine x cosine x equals 0. Well, hey-oh. And then if I factor out a negative sine x, this becomes 2 minus cosine x equals 0. Well, hey-oh, I have something times something equals 0. So then for this to be true, either that equals 0 or this equals 0. So I can say negative sine x equals 0. So sine x equals 0. Well, sine is 0 at your points 1, 0 and negative 1, 0. There and there. Yes, 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 yes. So already I have two solutions of 0, pi, and pi. Okay, for this part, 2 minus cosine x equals 0. Well, if I add the cosine to the other side, I'd have cosine x equals 2. This is not possible in any of our triangles, so there would be no solution for that part. So my only solutions would be would be 0, pi, and pi. Okie dokie. So with this one, I don't know if you can hear the music in the background. I'm sorry if it's distracting. Yeah. Uh-oh, now I'm going to get sued. Don't look this up. Band, whoever you are. Whoops. Okay, so with this, I see I have a squared term and I have an x term, or a regular term. If I rewrote this as like x squared minus x plus 9 equals 11, then I would move over the 11. I would have x squared minus x minus 2 equals 0. And then I could factor this as x minus 2, x plus 1 equals 0. And then I could just solve it from there, right? Well, it's going to be the same thing. It's just cosecant instead of an x. It's still treated like a variable. So if I have cosecant squared, sc squared x minus cosecant minus 2 equals 0, this will factor the same way that I actually did. So if you want, this could be a useful strategy. Change everything in terms of x, but be careful if you have different trig functions. So cosecant x and cosecant x. One's plus, one's minus. I have minus 2 plus 1 equals 0. So I can say cosecant of x is equal to negative 1 and cosecant x is equal to 2. Well, for the negative 1, that's where sine is negative 1 because cosecant is related to sine. So sine is only negative 1 straight down at 0, negative 1. So that would be at the point, or at the angle 3 pi over 2. And for this one, I have hypotenuse over opposite, 2 over 1. It is a positive, a STC. So sine is positive in the second and the first quadrant. And it would have to go from the angle pi over 6, 1, 2, root 3. So pi over 6 and 5 pi over 6 would put me in the second quadrant. There would be my solutions. Happy day. This one's kind of fun. I see that I have that in terms of cosine. So I could substitute and change sine squared in terms of cosine with my Pythagorean identity. So I would have 1 minus cosine of x equals 2 times 1 minus cosine squared. Right? Don't believe me, look at your Pythagorean identity that we learned in chapter 5.1. And then I can distribute the 2, and I can move over the cosine squared. So here we go. Do the math, do the math, do the math, do the math, do the math. Very good. I counted the toothpicks. Very good. Move over the 2, move over the 2. So 2 cosine squared x. I'm going to move this to the middle, so minus cosine of x, and then minus 2, so minus 1 equals 0. That will factor 2 cosine x equals 0. See, I have to have minus 1 plus 1 such that cosine minus 2 cosine comes out negative cosine. And then there we have it. We can continue solving. Happy day. Cosine of x equals negative 1 over 2. And cosine of x equals 1. What's up, Zaman?
How's it going?
Wonderful. So then if cosine is negative, You tried. You have all students take calculus. Cosine will be negative in the third and the second quadrant. For adjacent over hypotenuse, your reference angle is going to be pi over 6. So you will have x equals 5 pi over 6 and 7 pi over 6. And cosine is 1 only at the angle, what is that, pi? No. Ha! Ha! No! No! 0 pi. Okay, so this kind of ish looks like a trig identity. So what I'm going to do is I'm going to square both sides. So as long as I do one or something to one side, I can do the same thing to the other side. Or I have to, actually. So if I multiply this out, this would be, what, secant squared x plus 2 secant x plus 1 equals tangent squared x. And I know tangent squared x is what? Secant squared x minus 1? Yes, I looked at the ceiling. You can't tell, but I looked at the ceiling. So secant squared x plus 2 secant x plus 1 equals secant squared x minus 1. Okay, and then if I subtract the secant squared x to the other side, minus secant squared x, that makes 0, minus secant squared x, that makes 0, and then I'll move the 1 over, so I have 2 secant x equals negative 2. And I can divide by 2 and say that secant of x is equal to negative 1. Well, that is only going to happen when cosine is negative 1. That is only at the angle, what is that, pi? Pi. Yay, pi. Alright, hopefully this video has been informative for you guys. I believe in you. You can do this. Make sure you guys go back and look over the unit circle again if you forgot that. I told you needed to memorize it, but hey, if you didn't listen to me then, you better listen to me now. Otherwise, you're going to fail, so don't fail. Please don't fail. Yes, don't fail. Alright, good luck, you guys.